Hello, for my explainer video I had problem 3, which says suppose that a 100 kilogram football player running at 9.5 meters per second catches a 0.44 kilogram ball moving at a speed of 23.5 meters per second with his feet off the ground while both of them are moving horizontally. So I drew the picture for that, and I'm doing part A and B. In part A, it says calculate the final speed of the player in meters per second if the ball and player are initially moving in the same direction. And so how you're going to do that is, so for part A, we're going to take the player's mass, which is 120 kilograms, times the speed he is moving, which is 9.5 meters per second, and then we're going to add the 0.44 kilograms, which is the weight of the football, and then we're going to multiply that by the speed of the football, which is 23.5 meters per second. And then we're going to divide that all by the two masses added together. And whenever you do that out, make sure to use order. Oh, you can't even see. So it's the mass of the player times the mass, or times the speed where they're running, plus the mass of the football times the speed of the football, divided by the two masses added together. And make sure to follow orders of operations. That could be somewhere where you could mess up because it can be confusing. And so once you do that, for mine, my answer is 9.551 meters per second, which is the final speed of the player. And so part B says calculate the change in kinetic energy of the system in joules after the player catches the ball. And so I'm just going to do the page, and because it's a lot of work. So for part B, we're looking for the change in kinetic energy, which is delta KE, and it's in joules, which is the unit for work, I believe. And so what we're going to do is take 1/2 times the total of the masses added together, so that would be 120 plus 0.44 kilograms times the speed times what we just got, which is the final speed. So yes, the speed, but the final speed, my bad. Times the final speed, which is 9.551 meters per second. And we're gonna square that value. And then we're gonna subtract 1/2 times 120 kilograms. So it's going to be final minus initial. But because that's what the change is, so it's the change in kinetic energy from start to finish, or finish to start. And so it's going to be 1/2 times 100 kilograms times the speed squared, which is 9.5 meters per second squared, plus 1/2 times the mass of the football, which is 0.44 kilograms, times the speed of the football, which is 23.5 meters per second. And so the answer for that is negative 42.96 joules. So make sure to follow order of operations again in this. I know it's a lot because, or it can be confusing because this is on two different lines, but what you're essentially doing is final minus initial to get the total amount of work done, and it is negative because the kinetic energy, and it is negative because after the player catches the ball, there is less kinetic energy because they're not moving and they are stopping, and so therefore it would be negative, and potential energy would be positive and higher. So to refresh, part A is finding the final speed. So it's the two masses and speeds added together, divided by, or multiplied the mass times the speed, and add the other mass times speed divided by the total masses. That gets you your final speed. And the second part is change in kinetic energy. So final minus initial should be negative since they're stopping and there's going to be less kinetic energy. And just make sure to watch out for your signs and watch out for PEMDAS, so like order of operations,